Thanks, Maury, and thanks for the opportunity to be here. Thanks again for putting on a great conference. We have some slides. There we go. I want to talk to you today a little bit about Breakthrough Energy Ventures, how it came to be and what we're up to at Breakthrough today. The greatest challenge of our time is how to sustainably power the planet. And I want to talk to you a little bit today about that. There's three sort of big picture takeaways that I'd like you to keep in mind as we go through that. The first is that the greatest challenge that we have in the whole energy game is scale. We do energy at scales that dwarf any other human activity. And the scale at which we do energy in impactful ways has incredibly important ramifications for what we can and can't do. So it's always important to keep that in mind. The second is that the second challenge in the energy game is cost. Energy is the most undifferentiated product on the face of the earth, and people will not pay any kind of a green premium, right? People will pay a premium for things that they put in their mouth or on their skin. That's it. There's no green premium. So we have to do things at scale and at cost. And the third is because really I think as a consequence of those first two, there are no choices that we make in the energy game that don't have environmental consequences. So while it's always important to be mindful of the environment and the consequences of our action, we need to consider the consequences of new technology in light of the alternative, not in a vacuum. All right. The history of energy is a veritable history of modernity. The two are indistinguishable. And perhaps what's most amazing is just how short that history is. If you lived in the United States in the first half of the 19th century, you were probably involved in agriculture, because in 1830, 70% of the American population was involved in agriculture. And that work was backbreaking. An acre of wheat took 56 worker hours to farm, and it produced 15 bushels. Your day began at sunrise and it ended at sunset because there was no artificial light. Your heat was provided by wood. Your transportation was provided by animals. If you didn't emigrate, you probably never traveled more than 50 miles from where you were born. 2011 dollars per capita GDP was less than $5,000. Artificial light was arguably society's greatest need at that point, and by the middle of the 19th century, whale oil had emerged as the material of choice for providing light. But by the middle of the 19th century, that resource was becoming scarce. Whales were hunted both for meat and for oil, and were becoming scarce. People had to travel farther to find them, and oil was becoming more expensive. It became impractical. We needed a new technology to provide light. Already by 1846, Adam Gessner, a Canadian geologist, had demonstrated a liquid that he called kerosene could be distilled from coal, and it had basically perfect properties for the production of light, much better than whale oil. The challenge, however, was supply. You couldn't get enough of it. In 1851, Samuel Martin Kyer had demonstrated that he could get an almost identical material that he called carbon oil from crude oil. Again, there was a problem with supply. Oil seeps had been known in Pennsylvania for many years, but in 1859, the first oil well was drilled in Titusville, and the boom was on. John Rockefeller was involved with the production of oil almost from the beginning, and with his associate J.D. Flagler, they organized a Standard Oil, which very rapidly became the largest company, first in America and then in the world. Almost from the very beginning, an incredibly powerful relationship emerges between per capita energy use and per capita GDP. The ready availability of cheap, dependable light changed the world in ways that today are hard for us to imagine. At the beginning, even at the end of the 19th century, the average person used about 5 kilolumen hours of light. Today, the average person uses about 60 megalumen hours, a 12,000-fold increase. With access to artificial light, the workday changed. You controlled your day rather than your day controlled you. Productivity increased. New forms of energy enabled cooking, improving diets. And together, these seemingly modest changes began to have a profound effect on society. Second half of the 19th century, Oil was still used primarily for the production of kerosene and light, and what we call gasoline today was largely a waste byproduct. But other innovative forces were at work. Other things were underway. Early in the 19th century, a number of investigators had shown that if you passed various forms of electricity through various forms of a filament, you could produce light. But in 1879, Thomas Edison illuminated a device based on a carbon filament held in a vacuum. Electric light was a practical reality. Oil prices plunged. But other forces were at work. Other technologies were on the horizon. In 1908, the first Model T rolled off a Ford assembly line, introducing for the first time affordable, practical, gasoline-powered transportation. By 1914, a Model T took only 93 minutes to assemble on a Ford assembly line, and 20 years after its introduction, 18 million were registered in America. 1903, the Wright brothers flew at Kitty Hawk, ushering in an entirely new modality of transportation. And in 1927, Lindbergh completed the first transatlantic flight, changing transportation forever into a form entirely dependent on oil, on cheap, available energy. That link between energy and prosperity becomes even clearer as we go through the century, and for reasons today that seem obvious. In 1830, 70% of the American labor force was involved in agriculture. That number fell to 41% by the turn of the century, and at the end of the Second World War, less than 7% of Americans were involved in farm labor. That acre of wheat that took 56 hours to produce 15 bushels now took 3 hours and produced 31 bushels, a 50-fold increase in productivity. If you lived in the middle of the 20th century, you were probably involved in manufacturing. Electric light allowed you to control your day rather than your day to control you. Your heat came from oil or from coal. You traveled by car. The construction of the interstate system in the Eisenhower administration enabled vast migratory trends that changed the face of America. Those trends only accelerated through the second half of the 20th century as the true possibilities afforded by cheap, readily available energy became clear. Today, less than 2% of the American workforce is involved in agriculture, and America feeds the world. Real per capita GDP rose fivefold over the course of a single century. But while those changes in access to energy have enabled incredible prosperity, they bring with them incredible challenges. The energy that's available to us and that powers our way of life is available to only a very small fraction of the planet, roughly 20% of the planet. As the rest of the planet seeks the same level of prosperity that we enjoy, there are enormous challenges that lie before us, right? The resource that we've been using is finite. We can have an intelligent conversation about exactly how big that resource is and exactly how long it's going to last, but it is finite. And there are clear environmental consequences to the way that we use energy today, right? The last time the surface of the planet was as warm as it is today was 140,000 years ago, and sea level was 25 feet higher than it is today. The mean elevation above sea level of New York is 32 feet. The mean elevation above sea level of Miami is 6 feet. If we melt every scrap of ice on this planet, sea level rises by 220 feet. So the challenge before us then is how to sustainably power the planet. As we think about that, there's three things that we have to remember. The first is that energy is prosperity. The two are absolutely indistinguishable. The second is that today, 85% of the energy we produce from unsustainable fossil sources. And the third is that as the rest of the planet seeks to achieve an OECD lifestyle, energy demand will rise by roughly 2.5-fold between now and the end of the century. In 2015, at COP in Paris, the leaders of the OECD world announced Mission Innovation, an incredibly ambitious plan to double their country's expenditures on clean tech R&D by the end of the decade, by 2020. At the same time and on the same stage, Bill Gates announced the formation of the Breakthrough Energy Coalition, a group of 26 of the world's wealthiest and most influential individuals that was designed to be a private sector counterpart to the public sector Mission Innovation. A year later, in 2016, a subset of that group, 22 of the individuals, announced the formation of Breakthrough Energy Ventures, a $1 billion clean tech fund that was designed to invest in many of the technologies being developed through mission innovation. Breakthrough is designed to be different than other venture funds that have been investing in this space for a long time. There's certainly been no dearth of investment in clean tech. By some estimates, as much as $50 billion was invested over the last couple of decades, and it's all sort of disappeared. So Einstein's definition of insanity, right, doing the same thing over and over again and expecting a different outcome. The idea is to try and build a different sort of agency. So the fund is organized as a 20-year fund instead of as a 10-year fund, designed to better meet the time constant associated with these clean tech developments. We consider as one of our investment criteria climate impact. We will invest in technologies that we believe have entitlement to at least 0.5 gigaton per year of carbon equivalent greenhouse gases, so roughly 1% of global emission. The idea is we're going big here. We're seeking to bring other money to the table. $1 billion, obviously, in some ways is a lot of money, but compared to the magnitude of the challenge before us, it's not very much money at all. And so we're very interested in investing in a way that draws other money, new money, to these opportunities. We're deeply concerned with scientific possibility, and we've built a team that has deep technical expertise baked right into it. Spray and pray in this space doesn't work, right? Spray and pray doesn't work. We need a very different approach. And the fourth is that we want to invest in places where others aren't. We're not going to say something like we'll only invest in things that nobody else will invest in, but we are certainly looking for spaces that lack investment. You can see on the website a list of 42 so-called challenges, areas that we're interested in. We're more or less interested in some of the others, but basically we're active in the 5 spaces, broad spaces, that are responsible for the production of most of the world's greenhouse gases: electricity, transportation, buildings, manufacturing, and agriculture. If you're going to invest in spaces like this, things that have enormous timelines to meaningful and impactful deployment, you sort of have to do the ultimate Wayne Gretzky skate to where the puck is going to be and not to where the puck is today. And so you have to spend a lot of time thinking about, where do I think the planet is going and what's going to be impactful in 10 years' time and in 20 years' time. So we spend a lot of time thinking about the megatrends that drive the planet. So let's think about a few of those megatrends. Certainly one of the megatrends has been the explosive growth in the production of intermittent renewable electricity over the last several years, and at the same time an enormous drop in the price of that electricity. So intermittent renewable electricity today, people are routinely signing PPAs at under $20 a megawatt hour. So certainly megatrend number 1 is the production of enormous quantities of intermittent renewable electricity. And that brings with it a new set of challenges. That intermittency is something that we have to figure out how to deal with. Those intermittencies occur from time frames as short as seconds that have an impact on the quality of the electricity that comes out of your wall, to months, to seasonal storage. The solar insolation in Germany is 5 times in the summer what it is in the winter. That intermittency requires storage. The price of that storage, or what you can afford to pay for that storage, is inversely proportional to the time constant. If you've got a very short duration storage, you use that resource a lot, you can pay a lot for that storage resource. If you're going to use a storage resource once a year to use solar energy in December that you collected in June, it has to be incredibly cheap. Lithium-ion solves some of that problem, but at longer time domains, there are entirely new energy storage modalities that are necessary. And Breakthrough has invested in a number of those technologies. Malta is a molten salt storage technology that's good for sort of 12 to 24 hours. QuidNet is an underground, this is kind of a strange one, an underground compressed water energy storage modality. And Form Energy, Yetming Cheng, at MIT, looking at iron air, iron sulfur batteries, very cheap storage below even $1 per kilowatt hour that would enable both firming of renewable power to turn it into dispatchable power and to do seasonal storage. Unquestionably, one of the most ominous megatrends is the enormous or the explosion of the middle class, right? About 20% of the world is OECD, so it's the emergence of that other 80% who seek OECD lifestyles. And the emergence of that enormous middle class brings with it a number of important implications that we have to think about. CO2 emissions track linearly. So we said there's this incredible link between energy and prosperity, but because we produce our energy from fossil sources, there's an incredible link between prosperity and CO2 emissions. These are per capita CO2 emissions. For those of you sitting in the back of the room, this is a log plot, okay? That's how strong this correlation is. And that's a pretty scary plot. So let's think about the implications as this non-OECD world seeks OECD lifestyles. The first is just flat out access to energy. How are we going to produce energy? India is going to burn coal because that's what's cheap. So we have to think about other ways to do zero carbon baseload power to avoid the production of renewables. Nuclear energy is certainly one of the alternatives. The challenge with nuclear energy has been its cost, quite frankly. It's not safety, it's not waste disposal, it's cost. We have not been able to build fission anywhere close to affordable. There are a number of very interesting breakthroughs in fusion energy that may allow it to be built at scale and at cost, and Breakthrough Energy is an investor in Commonwealth fusion systems. Another important source of zero carbon baseload power is geothermal, and Breakthrough has done a couple of investments in the geothermal space. Fervo Energy is basically fracking for geothermal, directional drilling and fracking for geothermal. We've also invested in Baseload, which is a component of Clime-On, a Scandinavian company building low-temperature heat engines for the effective production of electricity from low-temperature thermal sources. Second incredibly important implication for the emergence of the non-OECD world is access to food, because it turns out there's an incredibly powerful correlation between per capita GDP and per capita calorie consumption. And not only calories, but meat. It turns out that there's an incredibly powerful correlation between per capita GDP and per capita meat consumption. And both of those things have incredibly important implications for the production of greenhouse gases. So let's think about those. One of those is nitrogen fertilizer. Remember today that the way we produce nitrogen fertilizer, ammonia, is through the Haber-Bosch process. The Haber-Bosch process is literally the reason that there are 7.5 billion people on this planet today. Without Haber-Bosch, the carrying capacity of this planet is probably 1/3 the number of people who are on this earth today. Another fun factoid you can use, in each and every one of you sitting in this audience, more than half the nitrogen in your body, all the nitrogen and all the proteins and all the nucleic acids, more than half the nitrogen in your body touched a Haber-Bosch catalyst. Haber-Bosch, of course, uses hydrogen that's produced from steam methane reforming and is responsible for roughly 1% of global emissions. So what are the alternatives to Haber-Bosch? Well, plants figured this out, right? We know that legumes evolved a symbiosis with rhizobium, in which the plant feeds an exudate of reduced carbon to those rhizobium, and those rhizobium use that energy to power an enzyme called nitrogenase that reduces nitrogen to ammonia and provides fertilizer for the plant. This, of course, is one of the reasons that farmers rotate crops, is to put nitrogen back into the ground. Unfortunately, that symbiosis never developed in plants that feed the world, in row crops of corn and wheat. Breakthrough Energy has recently invested in Pivot Bio, a company that has developed an organism that develops that same form, it's not exactly symbiosis, but the same form of nitrogen production for row crops. What about meat? Challenge with meat is enteric fermentation and the production of methane in the belches of ruminant animals, cattle and sheep. This is a big deal as well. If cattle were a country, they would be the world's third largest emitter, be China, the United States, and cattle. So thinking about meat alternatives is an incredibly important way to go as well, and there are a number of promising technologies on the horizon. Recently, Breakthrough has invested in a couple of these companies. Sustainable Bioproducts is using an organism that was isolated from a geyser, a hot spring, that converts carbohydrate to protein, a filamentous protein, at very, very, very high efficiencies. And so this is something that can produce protein at on the order of 50 cents a pound, perhaps even less. It's also filamentous protein, so it has texture to it, much better than things like bean curd and stuff like that for something like Impossible. Impossible, for those of you who've had an Impossible burger, really tastes pretty good. The key with Impossible is the addition of a hemoprotein, right? In real meat, it's hemoglobin. That's what gives the meat its red color, and also that distinctly metallic taste. Hemoglobin's a protein that's too difficult to express at scale to make something like synthetic hamburger, and so Impossible uses leg hemoglobin, a bacterial version. But even that protein is very hard to make. And so recently, Breakthrough invested in Motif. This is a spin-out of Ginkgo Bioworks in Boston that is producing many of these complex flavorants that'll go towards an ability to make plant-based meat. Another incredibly important implication of the emergence of this non-OECD world is mobility. And it turns out that, again, there's an incredibly powerful correlation between per capita GDP and per capita access to mobility. And that correlation is so strong that economists have actually suggested that a reliable measure of the size of a middle class is the number of cars in that middle class. That, of course, has enormous implications for the production of greenhouse gases. There are 1 billion cars on the road today. By some estimates, there will be as many as 3 billion cars on the road in 2050. Elon Musk, whatever happens to Tesla, fundamentally changed the world. He fundamentally changed the world by building a car that's not a golf cart, it's not a toy. This is a car you want to own because you want that car, not because it's an electric car. And that ushered in the beginning of a transformation that will take a very long time, but the beginning of a transformation to electric-powered vehicles. The production of batteries for those vehicles is an important task, and Breakthrough has made a couple of investments in this space. QuantumScape, of course, Jagdeep Singh, who's making solid-state lithium batteries that have roughly double the energy capacity, energy density of lithium-ion batteries. Cobalt Metals is using AI and advanced computational techniques to identify novel deposits of cobalt. And that's great, but gasoline is going to be with us for a very, very, very long time, right? Gasoline and liquid fuels are going to be with us for a long time because it's the most effective mechanism of storing energy you can possibly think of. We don't use gasoline because we're dumb. We use gasoline because if you gave a whole bunch of the very smartest scientists and engineers unlimited money and all the time they needed to come up with the perfect energy storage device, they'd come up with gasoline. So if cars and some large fraction of personal transportation can be electrified, there are other sectors of transportation that are going to be much, much, much more difficult to electrify. So thinking about how we can produce zero-carbon liquid fuels is something that we're very interested in. If you're going to do that, you need to start off with CO2, carbon, and energy carrier, and then the biggest cost of this is the source of energy, and that needs to be a zero-carbon source of energy, and put those two things together to produce a liquid fuel. I said earlier that people aren't going to pay a premium, right? People are not going to pay a premium. So if we mandate zero-carbon liquid fuels, that approach, whatever it is going to have to be cheaper than drilling stuff out of the ground, burning it, and then taking it out of the air later, okay? We believe that carbon capture is going to get down to under $100 a ton, including compression and storage. That's about $1 a gallon. So that's the premium you get to apply for producing a zero-carbon fuel in the first place. Well, how are we going to do that? The energy source is the tough part again, okay? The cost of gasoline, less than 1/5 of the cost of gasoline is the cost of the carbon. It's the cost of the energy that's important. So we need a zero-carbon source of energy. That could perhaps be the sun. There aren't very many zero-carbon sources of energy. If it's going to be the sun, then photosynthesis is a good way to store energy. If you're going to produce liquid fuels that can be cost competitive with drilling oil out of the ground and doing post-combustion carbon capture at $100 a ton, you're going to need sugars that cost less than 8 cents a pound. And we have no sugars in North America that we can produce for less than 8 cents a pound. There are sources of sugars, but those are the kinds of milestones you're going to need to hit to be able to produce cost-effective liquid fuels. If you want to do things other ways, if you want to capture solar electricity, make hydrogen, make syn fuels that way, you can do it, but that's the number that you're shooting at. There's some other very interesting things that are sort of bouncing around right now that could fundamentally change the way we think about a lot of stuff. In 1987 in Mali, folks were drilling a well for water. 240 meters, the well exploded. People assumed it was natural gas and capped the well. 2007, they went back and uncapped that well to mine the natural gas. And were surprised when they started extracting it to discover that it was not natural gas, but hydrogen. Since that time, a series of wells have been drilled in a several hundred square kilometer area around that original well. All of them have produced hydrogen. A number of these wells have been producing hydrogen consistently with no drop in pressure for over 5 years. So a really interesting question is where that hydrogen is coming from. If the source of that hydrogen is biogenic, if it's organisms that are digesting buried organic material, that's not very interesting. But there's a really intriguing possibility that it is in fact coming from the oxidation of serpentinite, of iron-2 that's buried deep in the ground. And in places where there's subduction that gives you both access to iron-2, to water, and heat, we can produce hydrogen. And Petroma, a number of companies, are exploring this possibility today. But this would be a real game changer if in fact this was persistent. Another incredibly important megatrend is urbanization. In 1980, there were 2 megacities on this earth, Tokyo and New York. Today, there are over 50, and I can guarantee you there's a dozen that you've never heard of. 70% of the built environment in 2050 doesn't exist today. And today, if you're on a job site, it looks exactly the same as a job site 50 years ago. We still use concrete and steel. We still use post and beam construction. Concrete is about 8% of global emissions. Steel is another 3% of global emissions. And so thinking about ways to mitigate the carbon produced in the production of concrete and thinking about new ways to produce iron are areas that are of great interest to Breakthrough Energy Ventures. We recently invested in Carbon Cure, a company in Nova Scotia that adds CO2 back into ready mix and reduces the amount of concrete that's needed, and Boston Metal, an extremely ambitious effort to do electrochemical production of steel. Not to be all Debbie Downer on such a beautiful day in Dallas, but megatrend 4 is that it's not going to be enough. There are by now virtually no even 2-degree scenarios that don't involve air capture of CO2. And if we're going to have to do air capture at the scale that it looks like we're going to have to do it at, this will be the largest industry that the planet has ever seen. And we have 40 years to build an industry 4 times larger than the global petrochemical industry. There are a number of people that are working on those technologies today, and we do believe that with enough innovation that we will be able to get these technologies to the point where they're affordable. Sustainably powering the planet is the challenge of our generation. The consequences of the 80% of the non-OECD world seeking the same standard of life that we enjoy today has incredibly important implications for us all. Breakthrough Energy Ventures was designed to be one small piece of that effort. We hope to attract other money, and I hope that we have an opportunity to work with many of the people in this room developing new technologies. Thanks very much.